All right, so in part one of this section, again, we are calculating equations in the form of mx plus b. In other words, all of the equations in this section are linear. It's in the form mx plus b, where m is the slope and b is the intercept. So the first one that I started with was just an everyday kind of a problem. I wanted to introduce this in common sense terms. The multiplier of the variable, in other words, times what is the slope, and the thing that you only pay once is what you start with, and that's the intercept. So if this is m times the variable plus b is the equation of a straight line. Here I wanted to prove to you that it's okay if you flip the order around. The multiplier of x is m, and the thing that you only pay once is b. And I'm ready to make some calculations. I'm actually going to save this one for the end. First, I'm going to solve this. It says, write an equation of a line whose slope is -3 and whose intercept is 5. And so I've got a couple of terms here that it's defined for me. It says the slope is -3, so it's going to say the slope is -3. And that's telling me m. And then it also says the intercept is 5, and that's telling me b. Okay, so I've got two things here. It's just telling me straight out that the slope is -3 and that the intercept is 5. Okay, and so it's just telling me what the equation should be. So in the equation, y equals m times x plus b. I know that I can replace m with -3 because m is equal to -3, and then I know I can replace b with 5. Okay, so the equation of this line is y equals mx plus b, or -3x plus 5. All right. So let's first identify now the slope and the intercept, and then we can use that to pick which one of these is the correct graph. This problem says, which one of the above is the graph of the line y equals -x minus 3? I'm going to have a look at each one of these to find their slopes and intercepts, and then I'm going to use that information to give me an idea of what I'm looking for. So the easiest thing actually is to find the intercept of each one of these things. So I'm going to go 1, 2, 3, 4, find the intercept for each one. Okay, so what's the intercept here, the intercept here, the intercept here, the intercept here. Okay, this intercept is halfway between, so it's right in the middle. It's right here. So the y-intercept up and down is 0 because it's right in the middle. The next intercept is -1, -2, -3. The point where the line runs into the y-axis is right here, and that occurs when you are at -1, 2, 3. So this is -3. This intercept is -1, -2, -3. It's in the between -3 and -4. So let me just call that -3.5 or -3.5. And the last one, the intercept, is here where y is equal to -1. So I can already tell what the answer is because only one of these has the correct y-intercept. I don't even have to find what the slope is. But we might as well find the slope. So I'm going to represent that with the letter m. So I'm just going to go all the way around and calculate all of these slopes. This is up 1 and sideways 2. Again, that was up 1, sideways 2. It's just that easy. The slope is 1/2. Okay, this one is down 1, sideways 1, down 1, sideways 1. So that means this slope is -1/1, or just -1. This one is up 1, sideways 2, up 1, sideways 2. So that's again 1/2. And then this one is down 1, sideways 1, down 1. Oh, not quite down 1, sideways 1. This one, I need to pick a better, this is a good point here. Down 1, 2, 3, 4, 5, sideways 1, 2, 3, 4. So it makes sense that that's close to -1. This is -5/4. Okay, That was a little bit tedious, but I just wanted to prove it wasn't too hard to find the slopes and intercepts in each one of these. The slope and intercept that we wanted was here. I wanted the slope to be -1. I'm going to put a 1 in front of the x, just negative x or negative 1x. So this slope that we wanted was -1, and the intercept that we wanted was here. The intercept that we wanted was -3. So I wanted a line that started at -3 and went down, and really the only one of these that starts at -3 and goes down was this one here. So this was the top right. Starts at -3 and goes down 1, sideways 1. Okay. All right, and now we're ready for the most difficult of the bunch. This is going to take a bunch of steps. So step 1, we're going to calculate the slope. Okay, and then step 2, we're going to calculate the intercepts. And then the last thing, step 3, we're going to write the equation. Okay, so, but it's not really all that bad. The slope is going to be the slope formula. So I want to do, here are my y's. So that's going to be y2 minus y1, and then here are my x's, x2 and x1. Okay, so that's y2 minus y1, and then the x's, x2 minus x1. And I can just go ahead and calculate those. -3 minus 0 is -3. And -8 and -4, these are the same numbers. There's no reason to cancel them. They're the same. So you wind up with -12. And the last step, I need to divide those two quantities to calculate the slope. So it's the rise over the run. Two negatives. A negative divided by a negative is a positive. And 12 divided by 3. 12 divided by 3 is 4. All right, so that was step 1, find the slope. All right, step 2, find the intercept. The intercept occurs when x equals 0. So if I were calculating the intercept, I would actually put x equals 0 into the function. But in this case, I've already got it. So x is equal to 0 right there. X is 0, that means y is 4. So that means b equals 4. Okay, so I've got my two quantities. M is 4 and b is 4. Okay, so I'm going to replace this m with 4, x plus, I'm going to replace the b with 4 as well. And that means the function is 4x plus 4. All right, so this was several different ways of thinking about slope-intercept form. The term that multiplies the variable is the slope. I represent it with the letter m. I can find m using the slope formula. And the term that's by itself that you only pay once is the y-intercept, and that occurs when x is equal to 0.